Good day everyone! Today it is finally time to fix the RGB of my wife's PC. As I said in the video where we built this PC, I will put a link here somewhere. The RGB controller of this old Alienware case hasn't been supported for quite some time now. So we had to come up with a solution. It has taken some time because the parts had to arrive from China. But now that they are finally here, we can get to work. Before we start though, I really do want to urge you to subscribe to our channel, because we have a lot more cool projects coming up. I'm really eager to fire up these 3D printers. We're not just going to build PCs, we're also going to build all kinds of custom electronics. So if you're interested in that, subscribe to the channel, press the little bell icon so you will get a notification whenever a new video comes up. And if you like this video, please press the thumbs up. Without further ado, let's get started, because this video is way overdue already. So if we take a look at this case, we should have RGB lights. I think it's here in the little Alienware logo. Yeah, it's in the Alienware logo. There's an Alienware logo on the front. Can you see it now? Yeah. So this one should light up. There's also RGB in the grill. It's symmetric. So the other panel is the same as this one. First things first, let's open this case. Because the neat thing about it is that while, let's show this first. While this door, it has a fan and it has RGB, it does not have cables directly connected to the inner workings of the motherboard or whatever, meaning we can just open it and take it out. What it does have is these seven connection points for which to control the RGB. And then we have the 3 standard pins for the fans, for the case fan. So the connection points on the door, they line up with these spring-loaded connection points here. I have to figure out how these are lined up, because some of them are connected, some not. And then they have this custom RGB controller, which also controls the fans. Nowadays, fortunately, we have everything on our motherboard. This current motherboard, it supports 2 addressable RGB lines, but I don't think we have addressable RGB in here yet. It supports 3 normal RGBs, 3 case fans, and then a pump and a CPU fan. One thing you might notice that's different from the last video is that this fan, the one we put on the radiator, we have swapped it because the one that Cooler Master gave us, I still have it laying around here. So the one that Cooler Master gave us, it was quite noisy. It was very noisy actually. So to get rid of the noise, we bought a Noctua fan. It cost a couple of bucks, but trust me, it was well worth it. And we also swapped out our Sabrent Rocket SSD for a gigabyte hours one, because the Sabrent Rocket, it just broke down. It broke down, and they are hard to get here in the Netherlands. So we're going for the gigabyte one, which is, in specs, it's nearly the same. Let's see how we get out this fan controller. So here we have the RGB controller. So mounted this way, yeah. So we have a big connector for the left panel, the front panel, and the right panel. It used to be connected via USB. It gets its power from Molex. Yes. So what this ribbon cable in the front does is pretty clear, since well, the connector might be quite big. You can clearly see it only has, well, how many lanes? 12, yeah. So it only has 12 lanes, which split up in these 3 connectors. So we have LED 8, 9 and 10. And then if we look at the circuit in the front of our case, and you cannot see this, but I can, we see LED 8, 9 and 10, which are actually 3 horizontal zones, so 3 levels of LEDs. I need to make sure I know which of these pins actually connect to what, so I can replace only this part and then just use all the old parts for the original case parts again, and then everything should work. So the idea is to make a very simple circuit that connects these huge connectors to the built-in RGB connectors for the motherboard, and then we'll see. So in order to figure out which pin of this connector connects to which of these connection points, we are going to measure it using a power measure tool. I'm guessing it's a one-on-one connection, but we have to test it. So let's see. The cables are. What this tool does is whenever it creates a short circuit, it starts beeping, which is convenient because now we can just test these pins and then see how they are connected. See? So now what I'm going to do is I can actually see this one being connected already. So I want to confirm that that is the one. And I can see that CN4 is the very, maybe I should start the other way around. Now, what I can see is that CN4, so the very last pin, is connected to the second pin, but if I have to mirror it. So this pin is connected to CN4. I'm calling this 1, I'm calling this 1. So I actually have all the information I need now for the left door. And now I also mapped all the other connectors. There are 10 controllable LEDs in total, so we have to come up with a way to control them from the motherboard. Since the motherboard has only 3 regular RGB headers and 2 ARGB headers. But the first thing we need to figure out is on how many volts these LEDs run, because I do see some of them are soldered on a circuit, so I'm not quite sure I can just put 12 volts on them. I could measure the output voltage of the Alienware RGB controller, but the RGB is set to a dimmed pink, so I'm pretty sure I will get a lower voltage than the LEDs need to get to max brightness, and I cannot change the output brightness of the controller. I found an old Chinese LED strip controller, so I hoped I could hook that one up, but unfortunately I could not find the correct remote to go with it, so I can't get it to turn on. What we can try to do is directly connect our 12 volt power supply to one of the LEDs to see if that works. It's not really scientific and we do risk blowing up the LED, but I'm pretty confident they run on 12 volts and it's nothing we can't fix. And we have light, quite some of it. These LEDs indeed seem to run on 12 volts, so we should be able to use the regular RGB connectors. It's time to come up with a plan, order some electronics to set everything up, and I'll get back to you after that.
Many months later.
So it's been a while, a couple of months actually, because I ordered most of the goods in China and it took a while for everything to get in. I'm going to have to take this apart again and then fit in the new stuff, and yeah, we will see what this brings.
A few moments later.
And the motherboard will stay put, and you can kind of see what I'm doing. Because I did buy these converter cables. They go from the old 4-pin RGB header, like you will find on your cheap Chinese RGB strips and everything, to the, what is this called again? To the connections that Alienware used. So, and these cords should be long enough to reach all the way to the back. So that is perfect. And there are actually headers for these on the motherboard, but only 2 of them. So to solve that, I've got some of these splitters as well. So we go from one regular 12 volt RGB connector to 2 of these Alienware connectors, for example. So we will lose a bit of configurability, but I don't think that's too bad, because for example, this one I will use to connect the left and right door. So that there was this little logo on the door, if you remember. And well, this way we can no longer control them separately, but well, now we are going to do that. And then I have another cable for all the other ones. So there's one RGB in to 4 of these RGB outputs. And what I'm going to use these for is for the icons. So near the front panel, the icons can be controlled as well. So the icon for the microphone, for the USB, for the firewire, for the headphones out, and then there's also one for the LEDs, like I said here. So that's all going to be one big group. So I know what you're thinking. You have 6 of these RGB connectors, but last time you said you only have 2 RGB headers on your motherboard. And you are right. But when I was trying to design this custom PCB, so this custom RGB controller to replace this, I was looking how to convert ARGB to RGB signals and stuff. And I even ordered some stuff to experiment with. Started experimenting without too much success so far, but I stumbled upon this. The Cooler Master RGB LED controller. So what this basically is, should be at least, it uses a USB signal and SATA power, thank you, to control 4 additional regular RGB LEDs. which is perfect because 2 from the motherboard plus the 4 from this make up 6. So everything was actually planned out. Let's see what else we have in this box. Yeah, because as you can see, the connectors here, they are very small. They will not ever fit such a connector. So they added some converters. This thing is magnetic, if I'm correct. Yes, so I can put it anywhere I want. Oh, that's quite a strong magnet as well. And now I'll have to connect these to these, but as you might guess, those are 2 females. So that will never work. But I also ordered a bag of these things. Just a regular connector that I can use to directly connect these cables. 1, 2, and 3 of these things. That would mean, let's see, this is 9, 8, and 10. 9, 8, and 10. 9 goes to 2. 8. That's this one, yeah. Goes to 3. So for anyone who has never worked with these RGB connectors before, there's this little arrow on there that I guess it points to the 12 volt and not to the R, the G or the B. That makes most sense to me. But at least that's how you should know how to place them. That might be in the manual actually. That's something we could, yes. The arrow goes to the 12 volt. So that was a good guess. I can even put it down there. Oh, that's actually not bad at all. Yes, I'm going to do some small rewiring. So I'll show you what I've done after that. I really should put something in front of that window I see now. It's a bit too light for the camera. Yeah. Anyway, as you can see, I've reconfigured some stuff, rewired everything. Most of the wires are now behind this back plate. There isn't too much room behind here. So the LED controller is actually stuck to the case here, to the top of the case. And that's how we can keep most of the wires out of sight. What I still have to do is connect this part to this connector. And for now I will only connect the LED, and the fan I will leave out of it. But that one will be connected later as well. But I just don't have the parts yet, so we have to make up something hideous, but at least it should work. We still have these little DuPont cables. So, yeah. So we're going, well, let's see, what is this? White, blue and green. Blue and green. Yes, and then red. And last time I mapped these connectors still had this little sticky note. So it's not the most pretty solution, but it's a temporary one, so it's fine for now. Let's close it up, hook her up, and see if we can get it to work. So while I was experimenting, I figured out that the wiring, you remember the Chinese cables, so that the ones that went from the regular RGB connector to the Alienware RGB, let's say it like that, the wires were hooked up wrong. And that means I will have to modify these cables. So what I can do just grab one of these. So that's all of them out. Now if I look at one of these connections, it's white, blue, green, red. So they should be ordered like this. White, blue, green, red. Seems about right. That's one of them. White, blue, green, red. Yeah, the white in here is actually black, but that should be fine. White, blue, green, red. Yeah. I think this is it. Only 9 more to go. The moment of truth. And frankly, I'm a bit scared. So far so good, eh? That's the DVD of the Blu-ray you're hearing. Finally, let's close the lid again to see if that one is working. I probably should not do this while the computer is still on. Oh nice, it immediately turned on. Very pleased with that. So, and with that, we've got the original RGB working again. But we have another thing, because we also have these ARGB headers. I decided to, well, buy the cheapest ARGB LED strips we could find. I think these were less than €1 a piece, but I thought I might stick them to the inside of the PC. I'm just going to use them for the inside. So the main difference between the RGBs from the case and these ARGBs is that the ARGBs only have 3 pins and they run on 5 volts. ARGB stands for addressable RGB, which means each LED has a small chip inside. Maybe you can even, I don't think you can see it. Well, there is a small chip inside which has an address, so every time the computer sends something over this wire, it gives it an address. So the LED with that address actually knows, oh, this is my message, and the other LEDs know this is not my message. And that's how you can individually control these LEDs. The problem with it, the risky thing about it is, a lot of motherboards like this one, they have both the ARGB and the regular RGB connectors. The ARGB runs on 5 volts, the normal RGB runs on 12 volts. That means if you would plug an ARGB into a regular RGB, you would blow up the LED strips. Fortunately, most companies, they close one of the holes, so you cannot accidentally put this on a 4-pin. Well, let's see how these perform. Not so far. Yes. Look. Now we have light. And it's even better with the lights off. I will also make a shot tonight when it's dark, but I don't know if my camera is going to like them. Anyway, this is it. The restored Alienware Area 51 PC, including working and controllable RGB. So that's how we fix the RGB of this Alienware PC. I do want to make a small note. I was assuming the Cooler Master RGB controller did have Fusion 2.0 support. Apparently it does not have. On the website of Gigabyte you can find multiple similar controllers that do have Fusion 2.0 support. I do recommend finding an RGB controller that fits your motherboard so you can control all the RGB with only one tool. So I hope you liked this video. If you did, please thumbs up, subscribe to the channel, it would be a great help, and we'll see you next time. See ya!